Hello everyone, Jai Hind, and welcome to the platform of StudyIQ IAS in English. And there was a news in today's Hindu newspaper that was about the re-entry of the Gaganyaan. At the same time, there is also a news that integrated airdrop test had been successfully conducted when it comes to IADT second test. So ultimately in this video, we'll be talking about the Gaganyaan mission, which is India's maiden human space flight program. And this complete program is being conducted, or it will be conducted by ISRO. Majorly by ISRO, but at the same time, Indian Air Force and Indian Navy are also part of the program. Now, when it comes to this program, so ultimately, this is the first time that a human space flight program had been planned in India, and it has been named as Gaganyaan. Now, over here, this will demonstrate that we have the indigenous capability to send the humans to the low Earth orbit, that is to up to 400 kilometers orbit. And ultimately, this will be a 3-day mission where 3 crew member will be there for this complete mission. At the same time, this is important that there will be safety first and a complete safe return to the Earth via sea splashdown will be there in the Indian waters, that is in the Bay of Bengal. And at the same time, when it comes to the mission, there will be precursion missions as well. There will be 2 missions that are planned, and they are basically uncrewed. All right, there will be no crew in these 2 missions, that is G1 and G2. And ultimately, they will test the system before the actual crewed mission that has been planned. At the same time, the crewed mission is named as H1. That will be a complete crew mission where we will have 3 crews which will be there in this Gaganyaan mission. Now, this complete Gaganyaan mission is of very important strategic importance for India, because this will establish India as the 4th nation overall in the world to launch humans into the space. At the same time, over here, there will be, the complete program had been built indigenously, and with the complete research and development that happened in India itself, we will be able to send humans in the space. This will create a platform for the microgravity experiments as well, and it will enhance our stature, the stature of India in the global space community as well. And ultimately, this will open the avenues for the future collaboration that we have seen that ISRO has achieved a milestone since the space journey has started, since our launch vehicles have been started, and ultimately now we are one among the trusted partners when it comes to launching of the satellites in the space. At the same time, the launch vehicle that will be used is LVM-3 M4. Ultimately, this was formerly it was known as GSLV Mark III, and it has been modified to meet the human rating standards, or LVM-3. At the same time, when it comes to the modifications, there had been solid strap-ons which had been, which will be put, and these solid strap-ons, that is S200, they will provide the massive initial thrust that is required for sending the humans or the crew module to the space. Then there is the liquid core as well, L110, that will use twin Vikas engines. There will be a cryogenic stage, C25, and this will be the high upper stage that will be there. At the same time, there is crew escape system as well, which is where we have the high thrust solid motors which are there, and they will pull the crew module away in the event there is any kind of launch failure. So this is the complete launch vehicle that we will have for the Gaganyaan. So this is the Gaganyaan mission where we have the crew module that is there. This is the habitat zone of the astronauts where the astronauts will be there. There is service module as well, and it will do the on-orbit servicing. And this is the complete orbital module that will be on LMV-3 Mark IV. That is a human-rated launch vehicle that we have. Now, ultimately, when it comes to the IADT-2 that has completed, this is the integrated air drop test that has verified the parachute systems which will be there for the Gaganyaan. Now, IF Chinook helicopters had been used to lift the module, and this module was released from the height of 4.5 kilometers above the surface of the Earth. And this complete test has validated the performance of the parachutes that will be there, the main parachutes and their deployment. And also it has confirmed the structural integrity, and also the system is reliable during the descent phase of when it will become, or it will do the re-entry into the atmosphere. Now, at the same time, when it comes to the Uncrewed Mission which had been planned before the crew mission, So there will be a robo, a space robo that will be accompanying the module. And this robo is known as Vyomitra. The Vyomitra will fly on the uncrewed missions to stimulate the human presence and also to test the life support systems that are there. It will also monitor the module parameters and operate the switch panels which are there on board, and ultimately it will also communicate to the ground station. It will provide the feedback on the internal environment that is there in the crew module. That is, it will provide the the complete feedback over the radiation, over the thermal as well as the vibrations which are there before the human astronauts they can be sent to the space in the crew module. Now, at the same time, it is very important to know that how this, the Gaganyaan, it will make re-entry, how it will re-enter into the our atmosphere and ultimately towards the Bay of Bengal, and it will splash into the Bay of Bengal. So, how this complete re-entry will be possible? So when it comes to the re-entry, the first thing is that when this Gaganyaan, it will be orbiting for the 3 days, it will have the speed that will be about, the velocity will be about 7,800 meter per second. And it is quite heavy, or it is quite very, very fast speed that is there. So ultimately at this speed, what will be there? We know that the kinetic energy is equals to half mv square, where kinetic energy is half of the mass multiplied by the square of the velocity. And ultimately when we have the velocity which is this much high, so the kinetic energy will be quite enormous and it will generate the heat that will reach up to 1600 degrees Celsius. So upon the re-entry, what is the first important thing is that the atmosphere, it will provide with the friction and that will create an aero-braking phenomena that will handle the majority of this because of the drag that will be put. Then later on we have the multi-stage parachutes which are there. Now we have different parachutes. The first parachutes will be the apex cover separation and they will initiate the deployment at the high altitude. Alright, later on we will have a drogue parachutes that will stabilize the module and ultimately it will reduce the speed to the subsonic levels. And then we will have the pilot and the main parachutes. These are the major parachutes, large parachutes that will be deployed at the height of around 12 kilometers altitude, so that the complete module, it can achieve the final touchdown speed that is of about 7 to 9 meter per second. And ultimately, when it comes to the redundancy system, this has been designed in such a manner that even if there is failure of one of the parachute, then also there will be the module, it will function safely and it will reach to the surface of the earth. Alright, at the same time, when it comes to the region where the splash or the landing will happen, this has been the site that has been taken care of, or the site that has been finalized, that is the water. Because when it comes to the land actually does not provide with the bounce. At the same time, when it comes to the water, there is, the water, it acts as a natural shock absorber, and ultimately the land, it requires braking motors. Whenever we are doing the landings on the land surface, there should be the braking motors which are there that will reduce the speed. Because when you are doing the land landings, so at that point of time, the speed must be about 1 to 2 meter per second. But at the same time, when we are talking about water, the water can absorb speed up to 7 to 9 meter per second. So therefore, it is quite intelligent to choose water as the safe landing spot for the Gaganyaan. Alright, at the same time, when we have the open sea, we have the Bay of Bengal. So that provides a large buffer zone. Because when it comes to the land landings, of course, you will have to see such kind of places where we do not have much higher population. And at the same time, in the Bay of Bengal, we do not have population that is there. So, of course, this is a safe landing spot. And the module, it will aim for, please remember, it will aim for a large ellipse elongated along the path of the travel. Because there are minor atmospheric density changes at the high speeds. And ultimately, when we have minor atmospheric density changes, what they do is that they cause the over or the undershoots. At the same time, there is minimal, minimal energy that is available for the sideway corrections. All right, there is very less sideway correction that happens, but yes, the module, it can overshoot or it can undershoot. So ultimately, keeping this deviation narrow, this keeps the deviation narrow, but also it keeps the deviation elongated, and that is why we have the elliptical elongated that is that is chosen when we have the re-entry of the Gaganyaan module. So this will be an elongated module, and it will not be a bullseye. Please remember, it will not be a circular or bullseye. That is very, very important. Now, how after the landing, after it splashes into the water, what will happen? So there will be a recovery phase, and this complete recovery will be undertaken by Indian Navy and under the Indian Navy's leadership. There will be GPS signals and the strobe lights that will be used for the precise location of the crew module, and ultimately bright green fluorescent dye will be released for the visual spotting of the module. At the same time, naval divers, they will secure the module with the flotation collar that will be attached to the module, and ultimately this flotation collar will be it will inflate automatically so that the crew module, it does not sink. At the same time, the module will then be winched onto the ship's deck for the crew extraction, and that is how the complete recovery of the crew module, it will happen. At the same time, when it comes to India's aspirations into the space in the future, so we have lots of aspirations, and this is just a step where we are moving ahead with a human flight into the space, that is Gaganyaan. Other aspirations that India have when it comes to the space exploration, that is that we intend to have a Bharatiya Antariksha Station, or BAS, that will be an indigenous space station by 2035. At the same time, we are also planning for lunar mission, where Indian astronaut, they will set their feet, their foot on the moon surface by 2040. And also we are moving ahead with the deep space exploration. We have already seen that we had the Mars Orbital mission, or the MOM mission, that was planned and it was successfully executed by the ISRO. At the same time, Gaganyaan serves as the foundation for the future interplanetary travels or the missions that will be undertaken by ISRO. So that would be all in this video, but at the same time, do not forget to join me on my Telegram channel. You can scan the code, or you can simply search me as @Bhanwar_StudyIQ. That would be all, but do not forget to share this video with your friends, and also drop a like to the video and subscribe to our channel if you are new to our channel, so that you do not miss any of the future updates. Thank you. Bye-bye. Take care and Jai Hind.